Okay. In section 22.13, talks about in the future you might be playing golf using electrical charges. So one day you might go on an interplanetary cruise. You're going to take a cruise spaceship to Mars. There you go. Okay. When you're in the middle of space, you can actually play golf, even though there's no gravity, by simulating it with electrical charges. Okay? So above in the right, you see the 24th century of golf. Protons in the putter will cause the protons in the golf ball to move away. And then we could use electrons to simulate gravity, to pull it down a hill, etc. Okay? Coulomb's law is well known, well loved, and well used because everyone in the 24th century is a nerd. They know Coulomb's law. There you go. Okay? To sink the putt in the first game, your putter must supply an initial force of 1.96 times 10 to the negative 25th newtons. Let me highlight that really quick, okay? So somehow you must have a really nerdy, you must have a nerdy caddy who can calculate that for you, okay? This will cause the ball to be rolling slowly as it reaches the hole, overcoming the force of friction due to the grass. If you apply too much force, the ball's not going to make it into the hole. Too much force. Actually, too much force will go past the hole. Okay. If you don't apply enough, it won't make it. So in other words, let's say I put on like 5 protons onto my putter. Actually, let's do 10 protons. Okay. And then I try to putt the ball. Notice that's not enough force, right? What if I put on like let's put on a lot more. Let's put on like I don't know. Let's do like 50. Let's go crazy. Okay. Oh, man, that's way too much, right? So you have to put on just the right amount. You see that? So in real life, when you play golf, you're actually adjusting your forces so that you get just enough so that it goes in the hole, right? So we're going to do this, but we're going to use electrical forces here, okay? So this is like nerdy golf. Back to the problem. The ball is initially 0.2 meters away, and the putter has an initial charge of plus E, where E is the charge of an electron, 1.6 times 10 to the negative 19 coulombs. What should be the charge on the putter? You can set the amount by specifying the number of protons. So we could keep guessing, but instead we should use whose law? Yeah, Coulomb's law. So let's see if we can help you figure this out so you don't have to keep guessing, okay? So here's you on your interplanetary cruise ship playing some proton golf in the 24th century. And basically you're going to add on a certain number of protons, we don't know how many, okay, on our first charge object Q1, so that your golf ball, okay, which has a positive 1 proton charge, will be repelled and fly all the way into the hole, and then you get a hole in one. Yay, okay? That's what we're trying to do. That's the basic idea, okay? So in step 2, let's list out all the info, okay? Q1 is the charge on the putter. That's what we're trying to solve for. Q2 is the charge of the proton ball, which has a charge of plus E, which is a charge of an electron, 1.6 times 10 to the negative 19 coulombs. That's the fundamental charge. They give us that the distance was what, 0.2 meters, I believe. There it is. And the question is then, how much charge should we put on our putter to sink the putt, okay, without just guessing randomly? Well, the only thing left we need to know is K in our equation, the electrical constant, which is 9 times 10 to the 9th newtons times meters squared over coulombs squared, okay? Don't worry about the weird units. It's just a constant that makes the equation work. Think of it like a fudge factor, okay, but a scientific one. So anyhow, we can apply whose law to figure this out? Coulomb's law, which states that the electrical force F is equal to K times Q1, Q2 over the distance squared, right? There we go. Okay, 1.96 times 10 to the negative 25th newtons. So now we'll just go ahead and put this into our Coulomb's law equation, okay? 1.96 times 10 to the negative 25th newtons is equal to our electrical constant K, 9 times 10 to the 9th, times Q1, which is a charge on the putter, times Q2, which is the charge of a proton, 1.6 times 10 to the negative 19th, divided by the distance of, what, 0.2 meters squared, okay? So this looks scary, but it's actually not too bad. It's just going to be a lot of algebra here, which is what we want to break down, okay? So I'm going to do 1.96, and then we'll do second E, which means times 10 to the negative 25th. I need to bring the 0.2 up on both sides, so I'm going to actually multiply to get rid of that, and then divide these two factors out to get Q1. Okay? So I'll multiply by 0.2 squared, divide by 9 times 10 to the 9th, the electrical constant, and then divide by Q2, which is 1.6 times 10 to the negative 19th. Okay? And when I do that, I get 5.44 times 10 to the negative 18th coulombs, which is the charge on the putter, but I need to know how many protons I need to put on to get that charge. So the charge of one proton is the elementary charge, 1.6 times 10 to the negative 19th coulombs. So if I divide my answer by the charge of a proton, 1.6 times 10 to the negative 19th, I get about 34 protons is what it's going to take, okay, to sink my shot. So let's see if that's right, okay? So instead of 50 protons, let's only put on 34, and if all goes well, woohoo! I use Coulomb's law to get a hole-in-one. Yay! In real life, if you play proton golf, you probably wouldn't sit there with a calculator. You would just keep messing around until you get it, until you get the shot in there, okay? And in real life, that's what you really do, okay? You adjust your shot based on the terrain conditions and your experience.